everyone. Thank you for joining me today. In this talk, I'm going to talk about what is OpenTelemetry and how you can use it to troubleshoot and monitor your production Elixir applications. So we are going to start with an introduction on observability in general. What is observability? I know this is a very hot buzzword today, but many people don't know what it actually means. Then we're going to talk about OpenTelemetry specifically, and we're going to do a live demo on how you can use OpenTelemetry to troubleshoot an application. First, a little bit about myself. So my name is Yosef Arbiv. I am married to Adi and father of three amazing young boys. I am a group leader at Cisco ETNI. My group is responsible for building and contributing code to the OpenTelemetry SDKs, and I was recognized as an CNCF ambassador. So let's start with some observability basics. So the definition of observability is that observability is a measure of how well the internal state of a system can be inferred from its external outputs. Meaning, you can say that your system is observable if you can know in which state the system currently is by looking on the outputs that your system produces. Let's try to understand what exactly does it mean in the context of software development. So let's say we have this basic application, let's say a web store, for example. So we have all of our logic running in one host. And the basic thing that we want to know about this application is whether everything is working as it should be, or do we have some problem with it? So what we usually would do is to install an agent on this host that will collect some metrics from the host. And then you can look on those metrics, hopefully on a dashboard, and see if everything is as it should be or not. And the next thing that we want to do is when we have some problem, let's say we have an alert or we see that one of the metrics is not as it should be, we want to investigate this error, right? So we need another agent to collect some logs from our application, and then you can look at these logs and understand why something happened. Of course, when our application grows bigger and bigger, doing this monitoring and troubleshooting become harder and harder. But I want to talk about different challenges that happens when we move from this kind of architecture to a microservices architecture, and moreover, to microservices that are managed by cloud providers. Nowadays, more and more companies are moving to those architectures, and it has a lot of advantages, but it also produces challenges to the development system. This is how a basic application, in this case, a demo application for a web store, looks like on a microservices architecture. You can see that this is a very complex diagram, and it produces a lot of challenges to the development team. So let's talk on three main challenges that we have when we are moving to a microservices architecture. Our first challenge is to model the system. If we go back to the definition of observability, we said that the definition is to know in which internal state your system currently is. So in order to know in which state your system is, you have to know in which states it can be, right? What are those states? What are the microservices that participate, that are a part of your system? Which one talks to which, in which flow, and so on. Even understanding this diagram, understanding which services do you have, which one of them participate in each flow, can be very difficult for the development team. So this is the first challenge when you're talking about microservices architecture. The second challenge is troubleshooting our application. Let's say that we have an alert that one of our applications has too many 500 errors. Searching for the root cause can be very difficult. We have to jump between different logs of different services and to narrow down to the microservice that is responsible for this error. Only then we can start investigating what happens inside this microservice, and then we can start to fix it, hopefully. The last challenge that I want to talk about today is optimizing our system. Let's say that one of our customers complained that a certain flow in our system is not as fast as it should be. Again, we need to look into all of the different microservices that participate in this flow. We need to understand what is the root cause of this behavior, and only then we can think of fixing this error. So in order to help us with those challenges, we have the three pillars of observability. We have metrics, logs, and traces. Metrics tells us what happens inside our systems. Metrics are basically numbers over a timeline, and we need to collect them from different aspects of our system. We can talk about business metrics, like how many items do we have in the cart, how many return transactions do we have, and how many checkout transactions do we have in our system. And we can also talk about development metrics. What is the saturation of our system? What is the duration of calls, and so on. Logs tells us why something happened inside our system. Logs are the most basic kind of telemetry data, and it helps to understand why something happens. It helps us during the investigation that we do. Traces help us to understand where something happened inside our system. And when we are talking about distributed systems, we'll talk about distributed traces. A distributed trace is a story of the entire transaction or a complete event as it propagates through our distributed system. So this is a representation of a distributed trace on a timeline. In this case, we have the operation A that triggered other operations. So for example, when operation D completed, the entire B operation completed, and then we had operation E. And when the operation E completed, the entire A operation was completed as well. So each tile here is a span. A span is a single unit of work that happened on a span of time. And all of these spans together are a distributed trace. This is another representation of a distributed trace, but this time on a graph representation. So you can see that here we had a checkout operation. You can see that we had other calls to different other services in our system in order to complete this operation. And you can also see that we had an error during one of these calls. So you can see how a distributed trace can help you to understand where something happened inside the system. And from here, you can jump to the logs of this specific service and investigate what exactly happened in this case. So now we all understand what is observability and what are the outputs that we should collect from our system in order to get a better observability of our systems. But now we have a new challenge. We are moving to microservices architecture. When we are moving to microservices architecture. So the first challenge that I want to talk about is modeling of our system. If we go back to the definition of observability, the definition is to understand in which internal state the system currently is, right? Whether or not we can understand in which internal state the system is. But in order to do that, we have to know what are those states, right? We can have a lot of different states. And understanding what are those states can be very hard. If we go back to this diagram, so even drawing this diagram can be very difficult when we have such a complex system. Understanding which are the microservices that we are using, which one of them participate in each flow of our system, which one of them is talking to one another. It can be very difficult for the development team. So this is the first challenge when we are talking about microservices architecture. The second challenge is troubleshooting our system. Let's say that we have an alert. We have, for example, too many errors in our system. In order to understand where this error comes from, we need to look into a lot of different microservices, Maybe we need to jump between different logs from different services. And we need to search in the different flows in our system that we have, so we can get the specific service that is responsible for this error. And only then we can start fixing it and actually investigating the actual error. And the last challenge is optimizing our system. Let's say that we have a customer that complains that a certain flow in our system is too slow. Again, we have to search in this flow between the different microservices that participate in this flow and correlating different logs. Maybe there is more than one microservice that is responsible for this error, and only then we can start investigating in the actual microservice and hopefully solving this issue. So in order to deal with those challenges, we have the three pillars of the observability. We have metrics, logs, and traces. Metrics tells us what happens in our system. So a metric is basically a number on a timeline, and we can talk about different metrics, for example, latency, duration of calls. We can talk on business metrics, right? How many items do we have in the cart? How many transactions do we have in our system, and so on. So metrics are the first signal that we get from our system. It tells us what is happening inside our system. The second pillar of the observability, the second telemetry data that we get from our system are logs. Logs are the most basic kind of telemetry data. I believe that almost every system produces logs, and logs tell us why something happened on our system. And the third pillar here are traces. Traces tells us where something happened on our system. So when we're talking about monolith applications, traces are like stack traces that tell us where we are in our big code. But when we talk about distributed systems, we need to talk about distributed traces. So a distributed trace is the story of a transaction or an event as it propagates through the entire distributed system. So this is an example of a visualization of a distributed trace. This is a single distributed trace on a timeline. So here we can see that we had operation A. Each tile here is a span. A span represents a single unit of work on our system, and all of these spans together are the single distributed trace. So here you can see that we had operation A. This operation triggered operation B, that in turn triggered C and D. And after that, we had operation E. And when operation E ended, the entire A operation ended as well. So this is another representation of a distributed trace. This time, this is a graph representation of it. You can see the different microservices that participate in this flow, and you can also see how a distributed trace can help us understand where something happened. So in this case, we had an error in the checkout operation, and you can see that the trace leads us to a specific microservice that was responsible for this error. So this way, a distributed trace can help us understand where something happened, and it can help us connect between the metric, let's say too many errors, to the logs of a specific microservice that is responsible for this error. Okay. So now we all understand what is observability and how metrics, logs, and traces can help us to increase our level of observability of our system. But now we have new challenges. So the challenge that we have in distributed systems nowadays is that we have a lot of different vendors and a lot of different tools that we can use. And this is an example from the CNCF landscape. This is just the beginning of a page much longer that talks only on observability and monitoring. And you can see that there are a lot of different tools. Some of them are public vendors. Some of them are are open source applications. But the problem is that we have too many tools, and even in one company, many times we have more than one, and actually about more than 5 and sometimes 10 and more tools for observability, because we have different services, sometimes by different providers. We have different teams in our company, right, that have different needs. Some teams needs metrics, other team needs traces, some need both. And in order to help those teams, many times we need more than one tool. And the challenge that I want to talk about here is the way that we produce the data. In order to produce the data, usually you have to install some agent or some SDK from this vendor in order to send you the data, right? And this challenge can be very hard, because when you want to move between different vendors, or even if you want to test different vendors, you have to install those agents, those SDKs, in different parts of your system. And this can take a very long time. It can be very challenging for you as a developer or as an SRE team. And it can be very, very costly for the company. So in order to deal with this challenge, we have OpenTelemetry. OpenTelemetry was created by the vendors of observability in order to deal with this specific challenge. The mission of OpenTelemetry is to enable effective observability by making high quality and portable telemetry ubiquitous. So OpenTelemetry tries to be a vendor neutral way to produce telemetry data, mostly metrics, logs, and traces. In the future, we hope to expand to more kind of telemetry data. But it tries to be a standard way of building this data and sending this data and representing this data in any kind of application that we have. So OpenTelemetry has a couple of principles that it follows. I will focus on a couple of these just to make you understand how we are trying to do that in OpenTelemetry. So the first principle is that telemetry should be easy. We want telemetry data generation to be easy and flawless for the development team. So the installation should be very fast, the configuration should be minimal, and you should be able to get telemetry data from our applications very fast. So OpenTelemetry is vendor neutral, and once you install OpenTelemetry, once you're sending data that is in the OpenTelemetry protocol and is done by the OpenTelemetry SDKs, you can be sure that you can use other vendors and you can move to other vendors and you can test other vendors seamlessly. And the last principle that I want to talk about is that telemetry should be built in. We try to create the telemetry built in to the applications, built into the frameworks that you use as developers, meaning that you don't have to install some agent afterwards. You can have the telemetry data built into your frameworks and into your applications from day one with minimal changes to your code. And we will see that in the demo in a moment. So this is a typical architecture of a system using OpenTelemetry. We can have APIs and SDKs of OpenTelemetry running in our code as a part of our system, as a part of our application. We can also have processor and exporters that process the data and export it to wherever we are using it. And all of this can be run as a part of our code, as a part of the OpenTelemetry libraries and SDKs. So this is the first part of OpenTelemetry. Then we have the collector. The collector is a tool that OpenTelemetry provides that can receive the data from one or many different sources. By the way, those sources can be also external to OpenTelemetry. If you already have some vendor-specific collector or producer, you can also send the data to OpenTelemetry collector. In the collector, we can also have processors and exporters, and we can export it to whatever telemetry backend that we are using, which is external to OpenTelemetry. So OpenTelemetry only deals with telemetry data generation and exportation. So what are the things that OpenTelemetry provides? The first thing that OpenTelemetry provides are the specifications. The specifications are the definitions of what is a trace, how a trace looks like, what is the structure of a metric, and so on. So this is a very important part when we define how are those signals actually look like in our code, and how are they built so everyone can use them afterwards. The specification also specifies what are the requirements and expectations from the different SDKs that are developed in each programming language. So what is the API that those SDKs exposes and how this API behaves? Then we have a language-specific SDK. So for every programming language, we have a project in OpenTelemetry to develop the SDKs for this language. And so we can have the APIs and the SDKs. The SDK is the implementation of the API in this specific language. So for example, to create a metric, to create a trace, to create a log, and so on. And we have extensions. So the extensions can be processors and exporter in this specific language that you can use built-in in your application. And there's another type of extension, which is an automatic instrumentation or just an instrumentation. So if you go back to this graph, you can see that we have different services, right? A lot of different services. And from each one of those services, we need to create a span, right? That specifies when this operation started, when it ended, what are the parameters, and so on. And of course, we don't want to do this work manually. We want it to be automatically. So OpenTelemetry builds instrumentations for the different frameworks that are used, that are popular in each programming language. And those instrumentations create those spans automatically for you. So you only have to initialize those instrumentation libraries. And in some programming languages, you even don't have to do that. You can just install the OpenTelemetry agent that does all of the discovery of the different frameworks and the installation of the instrumentations automatically for you. And those instrumentation deals with creating those spans, collecting the data from the request, and embedding it inside the spans, and also propagating the context between the spans. So we can connect the spans from the different microservices into a single distributed trace, as we see here. So all of this work is created for you by the instrumentations of OpenTelemetry. Let's talk a little bit about the collector. The collector receives the data from different sources. It can process it. So, for example, to omit some traces, to collect only 1 out of 100 traces, or to collect only error traces, and so on. And it can export the data to whatever backend that you are using. If you remember, I mentioned that there are exporters in the application. So why do we need a collector? So one reason to use the collector is if you want to remove the network operations from your application, so you have better performance in your application, and you have the network operations happen somewhere else. And it can also be used to have only one place in your application when you do this network operation, and if your entire, the rest of your application does not connect to the telemetry backend. And of course, there are other ways to use it. We have an amazing community in OpenTelemetry. It is actually the second most active project in CNCF right after Kubernetes, which is a huge project, actually the project that CNCF was established around. So this is an amazing and a very big community. We have documentation provided by the community. Of course, you have the GitHub repository of OpenTelemetry, a lot of different repositories when you can see issues and you can see the code itself. We have a lot of Slack channels inside the CNCF Slack space, when you can ask questions and search for previous questions, previous answer on specific projects inside OpenTelemetry. And this is actually the main way of communicating inside the OpenTelemetry community. Let's talk a little bit about the status of Elixir functions, the Elixir application SDKs, sorry, in OpenTelemetry. So officially in Elixir, the traces API are stable, and we have a lot of automatic instrumentations for a lot of popular frameworks in Elixir. The metrics and logs APIs are experimental, but I can tell you that the metric APIs are very close to be stable, so they are fairly stable, and you can use them to create metrics. And so you can go ahead and look on the Elixir the Elixir projects in the OpenTelemetry GitHub, and you can download it from there, and I'll show you in a moment how it is being used in the OpenTelemetry demo. So let's talk a little bit about the backend. So again, the backend is not a part of OpenTelemetry. The backend is external to the OpenTelemetry project, but we have many kind of different backends that support OpenTelemetry data. So first, we have many open source solutions that support OpenTelemetry. I want to mention Teletrace, which is an open source project that we released this week from the Cisco ETNI group that deals specifically with traces, and it supports, of course, OpenTelemetry natively. So you can check it out at teletrace.io, and you can see a short demo, and you can fork it, you can download it, and start using it. In the OpenTelemetry website, there is a specific page for vendors that support OpenTelemetry, and you can see the different vendors there. There are a lot of vendors that you can use according to your specific needs. And in Cisco, we also have the AppDynamics Cloud project, which is a project for monitoring cloud-native applications that also supports OpenTelemetry natively. So let's talk about the OpenTelemetry demo now. This is the most exciting part. I'll do it very quickly because we don't have much time. So the OpenTelemetry demo is a web store that is built in a microservices architecture with many different languages, and it also has Elixir built in it. So let's see it. So this is the documentation of the OpenTelemetry demo in the OpenTelemetry documentation site. And I already run it as a Docker layout on my machine. So let's open the web store. We have links for it in the documentation, and we can see that we can look in the web store and you can search for different products. But if you're looking on this specific one, we can see that there is some kind of an error. So let's try to look in Jaeger. Jaeger is an open source CNCF project for distributed traces. And let's try to search for an error trace. Okay, it takes some time. In the meantime, let's move to the Elixir microservice in the OpenTelemetry demo. You can get a sense of how it is done, how it is actually done. So the only thing that we need to do in Elixir is to call the specific setup of the frameworks that you want to instrument in our application. So in this case, we are instrumenting Ecto and Phoenix. So there is a simple setup a call, and we also have to add it to our dependencies. Okay, so we define here that we run the OpenTelemetry exporter and OpenTelemetry itself as a part of our application, and we add the dependencies to the specific libraries. Okay, but once we have done that, we have all of our traces from Phoenix and Ecto sent automatically, and we don't have to do anything else. So let's see if we have the traces yet. No, so I have some error here. Let's try it again. Yeah, so here we can see an example for an error trace. Okay, we can see that we had an error in our system. So you can see that we tried to get some catalog, some product from our catalog, and we had an error doing it. But I want to show you the traces from Elixir. In this case, this is the gRPC call to the Elixir microservice, and we can also see the database call that this operation triggered. So we can actually see what was the select query from our database. We can see the parameters. So you can understand how this kind of data can help investigate the error on your system and can focus you on a specific microservice that is responsible for this error, and even inside it, where to look. So with that, I will finish my. If you enjoyed this OpenTelemetry demo, you can check it out on the OpenTelemetry GitHub repository. You can download it and run it on your machine. I did it. It took me just a couple of minutes. It runs on Docker, so it's very easy to start. You can look on the Elixir libraries there, on the other libraries. And if you have any questions, I'm available on LinkedIn and on Twitter. And I look forward to hearing from you on this talk. So thank you very much.